Hello and welcome to this session on automating Jamf Pro deployment. Before we get started, I'd just like you to have a look at the Jamf's forward-looking statement, a full copy of which is available in the resources. So we'll just pause here for a few seconds. And then we will crack on. So my name's Andy Mackay. I'm lead systems architect for cloud services at a UK-based company called Trams Limited. We're a Jamf Pro hosting provider and also a Jamf managed service provider. And today I am going to be talking about how we automate the deployment of our Jamf Pro environments. So I'm going to give you a quick overview of the session, of our environments and how it works. We're going to have a quick recap on Jamf Pro scaling, which was a session I presented at JNUC 2 years ago. Then we're going to talk about how we automate our deployment, the evolution of our infrastructure, how to build Jamf in a container, and then a little bit about how we deploy into the cloud, in our case, Amazon Web Services. So first thing is, what do I know? Why am I here? So I'm responsible for an infrastructure that has around 100,000 devices enrolled in various Jamf instances, taking about 12,000 requests a second, to which we aim to provide 100% uptime and 24/7 worldwide access. So we run hundreds of Jamf instances, managing all those devices. As you can see, lots of requests, and we automate as much as possible. I say, if you refer you back to the previous session from 2 years ago, you can listen about how we like to automate for failover and high availability. So why automate? For us, there are four main reasons. Firstly, faster deployments. So deploying a new Jamf instance for us or doing an upgrade takes minutes. It's done by our first line support, and it is a repeatable process. That's another main reason. We get repeatable results. There's no human error in our automated deployment. It makes our upgrades easy and quick. So we can do an in-production upgrade of a customer, and depending on the number of changes being made by Jamf at the time, it takes around 15 minutes. And we also have automated recovery. If a server were to fail, we can automate reprovisioning those Jamf instances to a new server without any interaction from a human, just alerts to tell us what's happening. So if you want a recap on how you would scale Jamf Pro for high availability, how we do it, and some of the concepts that we employ, have a look on YouTube on the Jamf channel, and you will see my session at that link from 2 years ago, where we go into it in a bit more detail. This is kind of the next step along. So once you are scaling for HA, how can you automate those processes? So in the scaling, we talked about separating your Jamf and Tomcat servers from your MySQL and your Memcache servers. During this session, we will be concentrating on those Tomcat servers running the Jamf Pro server. If you want to hear about the MySQL side of things, Memcache, etc., have a look at the other session. So this video shows you the end result. So this is how we deploy a new customer into our environment. And like I say, this is done by our first line staff. We give it a name, we give it a version, we place it somewhere on our infrastructure, and then we let the system do its work. Now, I have deliberately deployed this using a slightly older version of Jamf, just so I can upgrade it in the next version, in the next video even, to show you that process. This is in real time, so we'll just wait and it will show you how quickly we can deploy a new customer using some of the processes that I'm going to describe in detail later. So we're building a container with Tomcat and Jamf in it at the moment, and then uploading it to our repository in Amazon. That's done. We're now waiting for that container to start. And this takes a small amount of time. So it's booting the operating system, starting Tomcat, starting Jamf, building the database, populating the database, and then when it finishes, we have an instance ready to go. This always takes longer when you're sat watching it on the screen. There we go. So we have now deployed a new instance to our environment. There's no manual intervention. That's ready now, sitting at the login screen, ready for a customer to log in. And I just want to show you a similar process, but how we would upgrade an existing customer. So this video, it's the same script that we're running, except we're going to upgrade a customer, enter their name, and it's going to go through and do an upgrade. Now, as I mentioned in the previous session, we don't actually upgrade Jamf Pro servers. So we actually build a complete new image with new Tomcat, new Java, new Jamf. We deploy that to our environment, and then we let it upgrade the database. The database is the only thing that's important here. Tomcats and Jamfs you can delete, you can spin up, you can move around, you can do what you like with. So we'll just wait for the system to start. This sometimes takes a little bit longer depending on how many upgrades to the database are required, but normally only a few minutes. And there we go. So that's an instance being upgraded to the version of Jamf Pro that we specified. It is now back up and running and ready for the customer to access. So that's where we are today. I do want to talk a little bit about how we got here. We didn't start with this infrastructure. It has evolved over time. So the first thing is, well, how has our infrastructure evolved? So we have two infrastructures. When we talk about it, we talk about our V9 infrastructure and our V10 infrastructure. Now, it's not our 9th and 10th version of that. It's literally the infrastructure we use to run Jamf version 9 and the infrastructure we transition to when we run Jamf version 10. So when we were hosting version 9 Jamf instances for customers, these were on large Tomcat servers hosting multiple Jamfs per server and what we call multi-context. So lots of individual web apps underneath big Tomcat servers. That has a few advantages and many, many disadvantages. The biggest disadvantage being if you need to do a full restart of Tomcat, it takes down every single customer on that server and it takes a very long time. I mean, at the end of our version 9 infrastructure, when we were running 30, 40 customers per cluster, it was taking hours to restart. So this has to be done out of hours, affects all our customers, we have to have maintenance windows. So one of the things we wanted to do when we were upgrading from version 9 to version 10 was to take that away, was to separate those customers more, allow us to restart individual customers, upgrade customers, and basically do things on one Jamf without affecting all of the others. So our version 10 infrastructure is very different. Our version 10 infrastructure doesn't have big Tomcat servers. It has lots of small Tomcat containers. So we use Docker running on obviously large underlying server clusters, but instead of having, say, 3 large Tomcat servers with lots of Jamfs underneath running our infrastructure, we have 3 containers per customer, each with their own Jamf. So we can restart customers, we can upgrade customers. It also means we can have people on different versions because they are completely separated on that environment. And that's really the core of our automation here. It's using containerized services. So in our case, Docker, to automate the deployment of Jamf. So we get into the sort of nitty gritty, if you like. This is our Docker file. This is how we build Jamf Pro in a container. Now, before we get into the specifics of what this is doing, it's worth explaining how we go about doing a Jamf build. So we don't build every customer from scratch. So we don't take a vanilla Tomcat image, put Jamf in it and configure it and upload that for every customer, because that would take a very long time. So what we do is when a new version of Jamf is released, we build a master container, and that's what this Docker file is for. So it takes down the specific version of Tomcat running the specific version of OpenJDK that we want. It then runs through the process to clear out Tomcat web apps, to copy the root war, so that is Jamf Pro, unzip it, and then copy various things like the server XML, the cache properties for memcache, a launcher script that we've written, which I'll come to later, some CSS files, some logos, and some jar files, which again, I will come to later, and then sets our Java options. So this is actually not, when we build this, this is not a Jamf container that you can just then start and have Jamf Pro. It's missing some key files. And those key files that it's missing are the customer specific ones. So we build this, which takes 5 to 10 minutes normally, once per Jamf version. And then we use that as the stepping off point for every customer. So when we build a new customer, we're saying build from our Jamf version. So if we were building Jamf 10.23, our thing would be called Jamf 10.23. So we know what version we're building from. And then we copy the 3 customer specific things in there. So we copy their database XML, their log4j.properties, and their memcache.properties. So that's the only things we're putting in when we build a customer instance. All the heavy lifting has already been done. Now you might be thinking, okay, database XML, that makes sense. Why a log4j.properties and a memcache.properties? I will come to that later, but suffice to say for now, we have to have some way of identifying the customers in this kind of shared infrastructure environment. So that when we send logs out or we send things to the memcache cluster, we know they're going to the correct customer environment. And that brings me on to logs. So as you've probably seen, building Jamf Pro in a container is pretty easy. I've included the Docker files previously. There's also an official Jamf image, which we don't use, mostly because it didn't exist when we built our infrastructure. But I encourage you to go and have a look at that. The interesting things or the more complex things come when, okay, you've got Jamf in a container, but then you need to think about all the other things that happen in the background. So, for example, logs. So by default, the logs are stored on the file system. So in Docker, the file system's ephemeral. So when you delete the container, as we do every single upgrade, all those logs go missing. So if you want historical logs of your Jamf, you need to send the logs somewhere else. And to do that, you either mount some persistent storage into your containers and store the logs as files on there, so that every time you spin up a new container, those files get repopulated, if you like, or you send logs to another system. Now, that's what we do. We send them to another system because that gives us more control, more insight into the platform. It also means that they are stored completely separately from Jamf. So even flushing logs in Jamf Pro, we still have a backup copy should something go wrong. So this is what that log4j.properties looks like. This is the extra stuff we've added towards the end. So we use a system called Graylog, and Graylog uses Elasticsearch. So it stores every single log from every single customer as a message in Elasticsearch. And that means we can do things like live querying of those log files. We can monitor for suspicious changes. We can get alerted if things are going wrong. Like, for example, Apple are having an issue with APNS, so we're seeing lots of APNS errors across all of our customers. Graylog can live filter those searches and send us alerts. One of the big reasons we use this and we use the Java method that I'm showing you here to send those files to Graylog, is it means that the built-in logging functionality within Jamf is still there, and the ability for a customer to send their log files to syslog server is still there. So our customers can still stream logs to their own syslog server. This doesn't affect that. You can see in here, basically it's a Java system, a Java plugin for log4j, which sends to Graylog. And the reason that we have a custom log4j for each customer is because it contains a subdomain. So we send all of our logs into the same Graylog, into the same Elasticsearch, but they're tagged with the instance it came from, the server that's running on, and the subdomain of the customer, so we can get some information. And that gives you an idea there of what's involved in configuring that. And then this is a startup script that we run. So when we start a new container, we don't want any manual intervention. So we want the logs to be streamed out to Graylog, and we want it to populate that log4j with the correct information. Because we're in AWS, this is very AWS specific, but there is an endpoint we can query on a local machine that gives us information, in this case, the host name and the IPv4 address of that host, and then we can tag that into our log4j. So you can see that here. We've got the environment is a subdomain, and we've also got midway down, it says origin host equals Docker instance. So that script is populating that origin host for us. So we know which of the servers running that customer is reporting an error. Again, useful information. So the final thing I want to really talk about here is how do you bring it all together? So you have Jamf running in a container, you have your logging sorted out. Is it just a case of putting that somewhere and off you go? Unfortunately not. So this is a really cut down kind of diagram of our infrastructure. And I just want to highlight really some of the steps that a request would go through to get to our customer instance. So like I said a few times, we use Amazon Web Services, and we try and use their platform and their services as much as possible. So we start right at the beginning. We start at Route 53. So Route 53 is a DNS provider. So when someone goes to, customer.transcloud.co.uk, Route 53 is the service that's responding with saying, okay, send that to this location. Now, our DNS doesn't actually return IP addresses of servers. What it returns is another Amazon service called Global Accelerator. And Global Accelerator allows us to get traffic from anywhere in the world into the nearest Amazon data center and then to our servers across the Amazon network. So instead of going across the internet all the way to our, let's say, data centers in Ireland, you will go into the Amazon network at your nearest data center and then use the nice fast Amazon network to get your data. It also has the side effect that we're able to assign static IP addresses to instances which are spinning up and down all over the place in the background, because it's a completely separate service. It then goes through our firewalls, and these are application level firewalls. So we are doing querying here on IP address reputation, making sure that bad actors are not getting access. We're also doing some rate limiting on APIs. We're limiting access to API documentation to approved addresses. We're basically adding an extra level of security on top of what's built into Jamf. And only then do we actually get to the main system. So the next thing that we hit is, if I go through these actually, let's just do that. So we had a firewall. The next thing that we hit is an application level load balancer. And this is really the first of the Docker type things. So when we start a container on Amazon's Elastic Container Service, which we use to run Docker. It registers those containers with a target group automatically, and those target groups, the application load balancer sends the traffic to. So if something comes in for customer1.transcloud, it says, okay, well, you need to send it to anything that's working in the target group customer1. So off it goes, and it sends that traffic out to our Elastic Container Service, which is basically Docker clusters running in Amazon. So it is one endpoint for us to manage, but it's got lots of servers and lots of instances running behind it. And then when we get from there onto the more back-end things, we've got MySQL running in Amazon RDS. And I talk more about this in the session from a few years ago about how we do MySQL replication and failover and things like that. But basically, it's an Amazon service. We allow it to do its job and it fails over automatically. And then we also have our Memcache cluster there as well. So all of our instances are talking to that Memcache cluster. And if you remember from a few slides back, they're sending their own subdomain along with that so that all their data is kept separate and they're only requesting their own things. Now, this is a very simplified version. I did try and draw out kind of actually how our infrastructure works and designs, but it becomes massive. This is a simplified version that basically shows you what's involved and what kind of scale you need to operate at to deploy things into a cloud environment for yourself. So thank you for listening. If you want to give any feedback, then you can complete the survey using the widget below, or you can also ask any questions using the Q&A. Thank you.